Okay, so in today's class, we are going to cover some transformation techniques, that is Z-transform. We will discuss some Z-transform for some standard signals like unit step sequence and impulse sequence. Also, we will discuss about the ROC. What is ROC and what are the ROC for different sequences? Next, we will discuss the DTFT, that is discrete time Fourier transform, and next is DFT, that is discrete Fourier transform. Okay, so you all might have studied some transformation techniques, like you have studied Fourier transform. You have studied Fourier transform or not? Kindly confirm.
Yes, sir.
Yeah. Yes. Okay. Any other transform you have studied? Laplace transform you have studied?
Yes, sir.
Okay. And Z transform, you have studied Z transform or not in mathematics? No.
No,
Okay.
sir.
Okay. So let's begin. What are the transformation technique? Basically, any transformation tool in mathematics is used to convert a function from one domain to another domain. Let's discuss about first Laplace transform. Okay. So Laplace transform, let me represent this as in short form LT. Okay, so what is Laplace transform? Basically, Laplace transform converts a time domain function, okay, into S domain. Okay, you might have remembered the formula for transformation. Okay, so if we have a time domain function, let us consider x of t, then its transformation in Laplace domain will be represented by x of s. Okay, now how we convert this x of t in x of s? So this is the mathematical expression which is used to convert a signal from time domain to s domain, that is integration minus infinity to infinity x of t e raised to power minus st into dt. Correct? Here s is the thing but the kernel, and the value of s is sigma plus j omega. Correct? So this is what we have studied earlier. And here s is also called as complex valued function. Okay, complex valued function. Okay. Also, this Laplace transform is used for continuous time signal. Okay, but it has some limitations. So to overcome that, we used Fourier transform. Okay, now how Fourier transform comes and how Laplace transform and Fourier transforms are related to each other. If I put 0, sigma is equal to 0 in this expression, then in that case, the value of S will be j omega. Now, if I replace this expression or equation, uh, instead of S, if I write j omega, then the expression will look like this. X of j omega is equals to integration minus infinity to infinity x of t e raised to power minus j omega t dt. And this expression gives us the Fourier transform of our signal. Okay, both Laplace and Fourier transformation techniques are used to convert a continuous time signal into a Fourier transform or a frequency domain representation or its equivalent frequency domain representation. Okay, now here we are going to discuss the Z transform, DFT and DTFT. Basically, these transformation techniques is for discrete time signals. Discrete time signals. Whereas the Laplace transform and Fourier transform is for continuous time signals. Okay. So this is the difference between Laplace Fourier and these transformation techniques which we are going to study today. Okay, now let us begin with the Z transform first. So you should write with me to make a proper notes of all the techniques and this expressions and problems also. So first write Z transform. Okay. So in this case, we have input sequence. Let us represent that sequence as x of n. And the Z transform of this input sequence will be represented by capital X of Z, correct? This is Z transform of x of n. Now, how we calculate this Z transform? So the mathematical expression is x of Z is equals to summation n is equals to minus infinity to infinity x of n into Z to the power minus n. So this expression is used to convert a sequence, time domain sequence into Z domain. Okay. Now what is Z? Z is basically a kernel, which is a complex valued function. Complex valued function. It is similar to S in we have studied in Laplace domain. So the equivalent part of S is the Z here. Okay. Now Z will be represented as Z is equal to R e raised to power j omega. Correct. Now, as you all know that the value of e raised to power j omega can be calculated like this: cos omega plus j sine omega. So basically, it is a complex number or complex function. Correct. Now, let's see what is ROC. ROC of a Z transform. ROC is called as region of convergence. Region of convergence. Basically, ROC gives you a range of values of x. Range of values of z for which x of z will exist. Okay. So all the values of z or the collection of values of z for which this z transform will exist is called as region of convergence. And usually we show this region of convergence graphically by using a z plane in which x-axis represents the imaginary part of z function and y-axis represents the real part. Okay. Now let us understand Z transform by using an example. Okay. So let me consider an example. Let x of n is equals to a raised to power n u of n. Okay. So this is the sequence and you have to find its Z transform. Okay. And also you need to plot the ROC. Also plot the ROC for this function. Okay. So this is x of n, the input sequence, correct? And we have to find x of z, that is Z transform. So we will use this transformation tool, this formula to calculate Z transform. So just put x of z is equals to summation n is equals to minus infinity to plus infinity. Just put the value of x of n as per the question. So in place of x of n, we will write a raised to power n into u of n into z to the power minus n. Correct? Now, what is this u of n? Can anyone tell me what is this u of n? Yes?
Unit impulse.
Yes, it is unit impulse sequence. And how the unit impulse sequence is defined? Actually, the value of u of n is equals to either 1 or 0. It is 1 when n is greater than or equals to 0, and it is defined only for integral values of n. Like u of 0 is equal to 1, u of 1 is equals to 1, u of 2 is equals to 1, like that. Okay. You might also aware about the plot of this impulse function. It look like this. Okay. You will get an impulse of amplitude 1 at 0, again an impulse of amplitude 1 at 1, and so on. So unit impulse sequence look like this. Okay, so here the summation is from minus infinity to plus infinity, but for the values from minus infinity to minus 1, this u of n is 0. So this summation will be changed from n is equals to 0 to infinity. And also for these values of n, this u of n is 1. Okay. So the expression will be changed to summation n is equal to 0 to infinity a raised to power n z raised to power minus n. Clear? Now we can also rewrite it like this also. Summation n equals to 0 to infinity a z raised to power minus 1 whole raised to power n. Correct? Now, if we expand this summation, first we will put 0 in place of n. So this value will be a z inverse raised to power 0. Next, we will put 1 in place of n. So it will be a z raised to power minus 1 whole raised to power 1. Next, we will put 2 here. So it will be like this. For 3, it will be like this, and so on up to infinity. Correct? So can anyone tell me which sequence is this? The sequence here you can see what type of sequence it is. Is it a progression, arithmetic or geometric? Yes? No one? Okay. Just recall this. Look, let us consider. Okay, look, listen to this. This value will be 1, correct? This value will be, we can write it as a by z to the power 1. We can write next values a by z to the power 2. Next value will be a by z to the power 3, and so on up to infinity. Now tell me which sequence is this? A plus AR plus AR square plus AR cube, and so on. Tell me the sequence which I have written here. Yes.
GP.
Yes, it is a GP.
GP.
Correct? It is a GP, and we have to find the sum of this GP. Okay. Now, how many terms are there in this GP? We have infinite terms. So, in order to find infinite terms of GP, it will converge, or we will get a finite value only when the value of R is in between minus 1 to plus 1. R means common ratio. When the common ratio is in between minus 1 to plus 1, or we can write when R is less than mod R is less than 1, then only the sum of infinite terms of GP can be attained. Okay. So let us consider that here the R. What is the value of R here? The value of R is A by Z. Correct? So let us consider that mod A by Z is less than 1. So we can find the sum of this GP. Now, what is the formula for sum of infinite terms of GP?
A upon 1
Anyone?
minus R.
1 by 1.
Minus R.
Correct. A upon 1 minus R. So here the expression, here the value of A is 1. So it will be 1 upon 1 minus A by Z. Correct. And the condition is mod A by Z should be less than 1. Correct. Now, if I simplify this expression, it will be like Z upon Z minus A. This is the value of x of Z. Correct. And the condition is mod A should be less than mod Z. Correct. Or I can also write it like this: mod Z, mod Z greater than mod A. Here. So the Fourier transform of this input sequence is x of z is equal to z upon z minus a. But this transform exists only when mod z is greater than mod a. Now, this is called the ROC of this transform. Okay. Now, how we can plot this ROC? So just understand this. Let us consider a z plane. So this is a z plane. This is imaginary part of z, and this is real part of z. Okay. So mod z, the plot of this mod z will always be a circle. So first we will plot a circle for mod z, and here mod z should be greater than mod a. Greater than mod a means the value of mod z should be outside this circle. So just shade outside region. Okay. Now this outside region represents you the ROC of this function graphical. Clear? Is it clear to all of you? Just confirm how we have plotted the ROC. Look,
Sir, can
the
you
value.
explain that circle part again?
Look, just understand this. What is Z? Z is equals to e raised to power j omega. Is it clear? Now, here we can also write Z is equal to R. This e raised to power j omega can be written as cos omega plus j sine omega. Is it clear? Okay. Now, here we have two parts. First one is real part, that is r cos omega. Second one is imaginary part, that is r sin omega. Clear? So when we plot these values, or you might have studied also the polar representation of a complex number. You have studied like this. If z is a complex number, if it is represented by suppose x plus iy, okay, x plus iy, then its polar representation, for its polar representation we replace x with r cos theta and y with r sine theta. Okay, now what is x and y? X and y are nothing but the coordinates of that complex number or point. Okay, so here r is the radius of that circle. Here, so if we represent any complex number in a complex plane and we convert that in polar form, then we will get a circle like this. Okay, if r is fixed and theta is changing. So it is because of that. But however, this part is not of your scope. You just need to understand that mod z represent your circle, and whenever you have an expression like mod z greater than a, then you will get ROC outside the circle, and you, if you have mod z less than a, then the ROC will be inside the circle. It is like this. It is the converging condition for the this sequence or the existence of that Z transform. Correct? Okay. If you have understood this, just tell me how you can calculate the Z transform of x of n is equals to u of n. Calculate the Z transform of this sequence and also plot the ROC. If you have not written the formula, let me write it for you. X of z is equals to summation minus infinity to infinity x of n z raised to power minus n. Just find the z transform of this expression and tell me what you are getting. What is your answer? Okay. Okay. How many of you are able to solve this? Just tell me, just acknowledge.
Solving, sir.
Okay. Yes, anyone who got the answer? The Z transform of that expression? Yes, if anyone got the answer, please let me know so that we can further move to another problem also. So here in place of x of n, you have to put u of n, and then uh, the summation will changes from minus infinity to infinity to 0 to infinity. In place of u of n, we will write 1, and here it will be z raised to power minus n. Further, when we simplify this, the expression will be like z raised to power 0 plus z raised to power minus 1 plus z raised to power minus 2 plus so on, like this up to infinity terms. Now, the sum of these terms will be a upon 1 minus r. So, obviously, a is 1. So, it will be 1 upon 1 minus z raised to power minus 1. So, the z transform will be z upon z minus 1. How many of you got this answer? Z upon z minus 1. Tell me.
Yes, sir.
Yes. Okay. Now, tell me the ROC. Yes. Anyone can tell me the ROC of this function? Look, I'm unable to see the check. Uh, yes, just repeat again. Mod Z,
Sir, outside the circle.
correct. Mod Z
Greater
greater than 1.
than. Yes, sir.
So it will be outside the circle, and the circle is of radius 1 unit. Whereas in the previous question, the radius of the circle was R. Okay. Basically, let me tell you some conceptual part related to this. Z is basically x plus iy. It is a complex number, correct? So if we write mod z, it will be under root x square plus y square, correct? Okay, so if this mod z is equals to a, suppose we are considering it as equals to a, okay? So on squaring both the side, what we will get? We will get x square plus y square is equal to a square. Okay, and this is a standard equation of a circle with center 0 comma 0, that is origin, and the radius as a. Here you might have remembered this equation of circle, standard form of equation of circle, x minus h whole square plus y minus k whole square is equals to r square, correct? So here h and k are 0 and the value of r is a. That's why it will always form a circle, and whatever in the right hand side will be the radius of that circle. Okay, so can anyone tell me the Z transform of another question, that is x of n is equals to 1 upon 2 raised to power n u of n? Yes, just tell me the answer. What will be the Z transform of this function? Also the ROC. Solve this, find x of z and ROC. X of z is equals to question mark. Also find the ROC. Okay. You can also use the previous results. In fact, I was thinking that you're doing the smart work by using the previous results, because in the first example which I had explained you, in that the Z transform of this function was Z upon Z minus 1, correct? So let me write that expression. In that example, a raised to power n u of n, the Z transform of this function was Z upon Z minus 1, Z minus a, and the ROC was mod Z greater than a, correct? Now, in order to solve the first question which I have given to you, just what you have to put here, just put a is equals to 1 and you will get this signal. Okay. Similarly, for the transform also, what you have to do, simply you have to put a is equals to 1 in this condition and you will get the Z transform of u of n, correct? And same for the ROC also. Here the ROC is mod Z greater than 1. So simply put 1 in place of A and you'll get the ROC. Okay. And apply the same thing for this function also. And tell me what will be the Z transform of this x of n by using previous results like this. Okay. X of Z is equals to, repeat.
Z upon Z minus 1 by 2.
Correct. It will be Z upon Z minus 1 by 2. Correct. And the ROC will be mod Z greater than 1 by 2. Okay. So here you will have a circle with radius 1 by 2 and the ROC will be outside this circle. Correct. So this is what some examples of Z transform, some questions based on Z transform. Now, let me give you another question related to Z transform. Uh, Tell me the Z transform of del of n. Del of n is an impulse function. Okay. Tell me the Z transform of this function. Also tell me the ROC. Yes, can anyone tell me? X of Z, the transformation equation is n is equals to minus infinity to infinity x of n Z raised to power minus n, correct? So what you have to do here, you have to put del of n in place of x of n. So the equation will be like summation n is equals to minus infinity to plus infinity. Here it will be del of n Z raised to power minus n, correct? Now, if you know the mathematical background of this del of n, that is impulse sequence, then you will be able to solve this. Just tell me what is del of n, how it look like in the graphical representation. The del of n is an impulse sequence, and here you will get an amplitude of 1 when n is equals to 0, correct? Elsewhere, the value of del of n is 0, correct? So, yes, correct. So, it is 1 only when n is equals to 0. So, simply you have to put n is equals to 0 here. So, it will be Z raised to power 0. So, del of 0 is 1. So, simply you will get x of Z is equals to 1. That's it. So, the Z transform of del of n is 1. Correct? Now, tell me what is ROC? ROC for x of Z. Yes, any guess? What could be the ROC of this function? It will be all Z plane. It will be all Z plane because there is no terminating condition. Because in previous cases, we are getting ROC when we have to find the sum of infinite terms of a sequence. Okay, and for that we were considering that mod R is less than 1. Okay, but here we are getting only one term, so it will converge. We don't need to put any condition here. Correct. So the ROC of this function will be complete Z plane. Okay. Now let me give you some more standard transforms like minus u of minus n minus 1. The Z transform of this function will also be same Z upon Z minus 1 like u of n. Just one thing gets changed, that is mod Z will be now less than 1. Okay. You can simply apply the same function in that Z transform formula and you can derive this expression. Okay. Similarly, the Z transform of a raised to power minus a raised to power n u of minus n minus 1 will be Z upon Z minus a. Similar to that previous expression, what we have derived for a raised to power n u of n. Okay, if we flip the signal, then also the Z transform will be same. Just one thing gets changed, that is the ROC. Here the ROC will be mod Z less than A. It means inside the circle. So in this situation, we will get ROC inside the circle in both these conditions. Okay, whereas in the right sided signal, we will get ROC outside the circle. So basically, here if you plot this sequence, you will find that this sequence are left sided sequence. Basically, the plot of these sequence will be on the left hand side. Okay, and the ROC will be, in this case, will be inside the circle. Whereas the sequence like a raised to power n u of n, the sequence will be right-sided sequence, and the ROC will be outside the circle, like that. Okay, so this is the conclusion which we can understand with this. Okay, now let us discuss about some of the properties of Z transform, like Fourier series, Fourier transform, and Laplace transform. We have properties for Z transform also. Almost the similar properties are there. Let me discuss in brief. The first property is linearity property. Okay. Now, what is linearity? Suppose we have first sequence x of n, and the Z transform of this sequence is capital X1 of Z. Another sequence x2 of n, whose Z transform is capital X2 of Z. Okay, so the linear combination of x1 and x2, let us consider a x1 of n plus b x2 of n, will have a Z transform, that is a capital X1 of Z plus b x2 of Z, like this. Okay, this is the linearity property. Second is time shifting property. Time shifting property. Suppose we have an input sequence x of n whose Z transform is like capital X of Z. Okay, then if we shift the sequence in time domain by n naught, so let us consider xn minus n naught, a function is there, then the Z transform will be multiplied with Z raised to power minus n naught. Okay, so this is the shifting property. Third is multiplication by Z raised multiplication by Z naught to the power n. Okay, so suppose if we have x raised to power n with Z transform x of Z, and if we multiply this x of n with Z raised Z naught raised to power minus n, in that case, the transform will be multiplied with x of Z will be replaced with Z upon Z naught. So this is multiplication property. Next is time reversal property. time reversal property. If we have an input sequence x of n and whose z transform is capital X of z, then if we reverse the time frame, or we can say if we write x of minus n, then in z domain it will be x of z raised to power minus 1, like this. Okay. Uh, Next is multiplication by n. Multiplication by n. So if we have a function or signal x of n with z transform capital X of z, then the z transform of nx raised to power n, nx of n will be minus z d by dz of x of z. It will be like this. Okay. So you can simply find the z transform of n u of n. Can anyone tell me the z transform of this signal? Z transform of this signal by applying this property. Okay. So initially, to find the z transform of nx raised to power n u of n, we need to know the z transform of u of n, and that we have already derived in previous questions. Okay, and the derivative and the z transform of u of n is z upon z minus 1. Correct. So since we are multiplying with n, so in z domain, we have to write minus z d by dz of this derivative. Correct. So what you have to do, just differentiate this expression and multiply it with minus z, and you will get the derivative of n u of n. Correct. So just try to do it by your own and you will be able to find n u of n, the z transform of this function. Correct. Similarly, if you want to find n square u of n, then again you have to multiply with minus z and you have to find the derivative of that previous step. Correct. So you can try it with your own and you can find the z transform. Correct. Also, some pair of some standard functions along with their z transform and with ROC is given in different books. You can follow Schumann series. Here you can find many of the z transforms, many pair of the z transforms. Correct. Now let's move to next property, that is convolution property. Convolution property. Okay, suppose we have two input sequence x1 of n with z transform capital X1 of z and x2 of n with z transform capital X2 of z. Okay, if we convolve these input signal in time domain, so it will be represented like this: x1 of n convolution with x2 of n. Then in z domain, it will be x1 of z into x2 of z. You might have already studied the convolution property for Laplace transform and Fourier transform. So the same properties are applied for z transform also. Just one change is there. Here we have n instead of t and z instead of s or omega. Correct? So these are some of the properties related to Z transform. Many other properties are also there. You can follow Schumann series, or these 6 properties are also sufficient. And try to solve some problems from the book in order to practice more about the Z transformation techniques. Okay. Now let's move to the next topic, that is DTFT. DTFT. The full form of DTFT is discrete time Fourier transform. Discrete time Fourier transform. Actually, DTFT is basically The small changes in Z transform will resulted in DTFT. Now, let me explain you how the chronology works. Look, in case of Laplace transform, we convert time domain to S domain, correct? And also in case of Fourier transform, we convert time domain to omega domain, Laplace transform, and this is for Fourier transform. Now here S is equals to sigma plus j omega, correct? So if we consider omega is equal to 0, then when we replace S with j omega, we will get the Fourier transform. Clear? So simply S is replaced with j omega, you get the Fourier transform, and in similar way, the Z, which is equals to R e raised to power minus j omega. So when you put R is equals to 1 and replace Z with e raised to power minus j omega, that will be called as discrete time Fourier transform. Okay, so let's see what was the mathematical expression for Z transform. It is x of Z is equals to summation n is equals to minus infinity to infinity x of n z raised to power minus n. So simply replace z with e raised to power minus j omega in this expression. Then the expression will be like x e raised to power minus j omega is equals to summation n is equals to minus infinity to infinity x of n e raised to power minus j omega n. That's it. And this is the equation for or to calculate the DTFT, discrete time Fourier transform. Okay. And this part x of e raised to power j omega is called dt of t of the signal x of n. Correct. Now let's discuss some points related to DTFT. So DTFT of a signal is always continuous. However, we are finding the Fourier transform of discrete sequence, but the discrete time Fourier transform of this sequence will be continuous. Correct. Suppose let me explain you with one example. How many of you remember the Fourier transform of gate function? Gate function or the rectangular pulse? Can anyone tell me the Fourier transform of rectangular pulse? How it look like? Yes? No one? So it basically look like this. Okay? Sampling function. So if we discretize this gate function, okay, then also we will get this continuous type of uh, continuous function in case of Z domain, or you can say the frequency domain. Correct. So this is the first property, that DTFT of a signal is always a continuous function of omega. Next is it is also a periodic with time period of 2 pi. So these are some of the most important property. Now let's understand DTFT with one example. Okay, so let us consider x of n is equals to 1 by 2 raised to power n u of n. Okay, and consider another signal y of n is equal to x square of n. Okay, and you have to find discrete time Fourier transform of y of n. Now, how we can calculate discrete time Fourier transform of y of n? So first, we have to find the mathematical expression for y of n, because the expression for x of n is given to us. Now, can anyone tell me what will be the expression for y of n? What if we square this x of n? Then what we will get? Tell me. Yes. Okay. So it will be like 1 by 2 raised to power 2n.
U square
Yes. Into u
U
square of.
of n.
Now, what will be the value of this? Tell me. Its value will always also be u of n. Correct? Because if you multiply two unit impulse sequence, then you will get the same unit impulse sequence. Look, uh, the u of n, the plot of u of n is like this. Okay. And consider another unit impulse sequence like this. Okay. Now, if you multiply these two sequences, this is u of n, this is also u of n. The multiplication will be based on time axis. So 1 into 1, you will get one same number. Similarly, here also 1. Similarly, here also 1. So multiplication of u of n into u of n, you will get u of n only. Okay. So here the y of n will be 1 by 4 raised to power n into u of n.
U of n.
Correct. Okay. Now, tell me the Z transform of this y of n. So y of e raised to power j omega is equals to minus j omega is equals to. I'm just putting the value of this y of n here in this form. Okay, so it will be summation n is equals to minus infinity to infinity x of n. So in place of x of n, it will be y of n because we have to find the z DTFT of y of n. So it will be 1 upon 4 raised to power n into u of n into e raised to power minus j omega n. Correct? Now, if we simplify this, so the limit or the summation from minus infinity to infinity, which was initially, now it will be changed to 0 to infinity. So we will get summation n is equal to 0 to infinity because we have u of n here. That's why the summation is changed to 0 to infinity. 1 upon 4 raised to power n e raised to power minus j omega n. It will be like this. Now, if we expand this, just put the value 0. So it will be 1 upon 4 raised to power 0, e raised to power 0. Now put the value 1, n is equals to 1. So 1 upon 4 raised to power 1, e raised to power minus j omega. Next put 2. So it will be 1 upon 4 raised to power 2, e raised to power minus j omega into 2, like this. And so on up to infinity. Correct? Now, here obviously the first term is 1 and second term which we can see e raised to power minus j omega by 4. The next term is e raised to power minus j omega by 4 whole square, and third term is whole cube, and so on. So again it is a GP, and the sum of infinite terms of GP, we will apply that formula a upon 1 minus r. So it will be 1 upon 1 minus e raised to power minus j omega by 4. And after simplification, we will get 4 upon 4 minus e raised to power minus j omega. Yes. Any doubt? Okay. So this will be the DTFT of that signal. Also, what you can do, you can also simply calculate the Z transform of this sequence. And after calculating that Z transform, just replace the Z with this value, e raised to power minus j omega. You will get the same answer. Correct? So this is what the DFT. Okay. Now let's move to another topic, that is DT. So sorry, this is DTFT. Now let's move to the another topic, that is DFT, discrete Fourier transform. Also, let me tell you what is the difference between DFT and DTFT. Basically, DTFT is for infinite time sequence like this. Here we have y of n is equal to 1 by 4 raised to power n u of n. Here u of n is not a finite time sequence. It goes up to plus infinity. For such signals, we apply DTFT. Whereas if we have finite time sequence, then we apply DFT. Correct? So in case of DFT, the full form of DFT is discrete Fourier transform. Discrete Fourier transform. Okay. And it is for finite duration sequence. It is for finite duration sequence. Okay. So let us consider that x of n is a finite duration sequence. Is a finite duration sequence. Okay. Of length L. Of length L. Okay. Suppose x of n is equals to 1, 3, 5, 2, 1. So this is a finite duration sequence, and let us consider that the sequence start with this point. So it means the value of x of 0 is 1. Then the next value x of 1 will be 3. X of 2 will be 5. X of 3 will be 2. And x of 4 will be 1. Correct? So we have 5 values here. So this is a finite length sequence or finite duration sequence. Here the length L is 5. Correct? Now, in order to find DFT of these signals, first we have to define the points of DFT. Okay, so the points of DFT is represented by capital N. N is points of DFT, and the value of N will always be less than or equals to L minus 1. So in this case, the value of L is 5. So here, at most, we can have 5 minus 1, that is 4-point DFT. Correct? Now, what is the mathematical expression to calculate DFT of an input sequence? Okay, so if we have input sequence x of n, which has points like x0, x1, x2, x3, and so on. Okay, up to xn minus 1. In that case, the n point DFT, the n point DFT of x of n will be represented by x of k. Okay, and the x of k can be calculated using this mathematical expression: summation n is equals to 0 to n minus 1 x of n into wn raised to power kn. Here wn is nothing but twiddle factor or kernel, which we can say, and its value is e raised to power minus j2 pi by capital N, and capital N is that point of DFT. Correct? So if we put this value here, the DFT formula will be x of k is equals to summation n is equals to 0 to n minus 1 x of n e raised to power minus j2 pi by capital N whole raised to power k into n. Okay, so this formula represents the DFT, how we find the DFT of any sequence. Similarly, like with any other transformation tool, if we transform a sequence or signal from one domain to another domain, we can also do the reverse process. That is called inverse transform, like inverse Fourier transform, inverse Laplace transform, like that. Similarly, in case of DFT, we have IDFT, that is inverse discrete Fourier transform, IDFT. So in order to IDFT, we will find x of n from the sequence x of k. Okay. So the mathematical expression for that will be x of n is equal to 1 upon n, summation n is equals to 0 to n minus 1, x of k, wn raised to power minus kn. Here also the value of w is same. Here w is nothing but Riddle factor. Okay. Now let's understand this with an example, how we can find the DFT of any sequence. Okay. So let us consider that a finite time sequence x of n is given by 1, 2, 1, 2. Okay. And we have to find the 4-point DFT of this input sequence. Okay. So first of all, uh, it its length will be 4, and similarly the value of n is also 4, because we have to find 4-point DFT. Correct. And the DFT of this x of n will be represented by x of k, and this x of k will contain 4 points, that is x of 0, x of 1, x of 2, and x of 3. Correct. Now how we can find x of k? So the expression for x of k is summation n is equals to 0 to, here it is n minus 1. Correct. So the value of n is 4 in this case. So 4 minus 1, so it will be 3. So here the summation is from n is equal to 0 to 3. Also we will write x of n here, and e raised to power minus j 2 pi upon 4. Now look at this point. Here it is e raised to power minus j 2 pi. So that's why we have written e raised to power minus j 2 pi, divided by n is there, and the value of n is 4 here. So that's why we have written minus j 2 pi by 4. Then whole raised to power. Here kn is there. Now write k as it is and n as it is. Okay. Now in order to find x0, what we will do, we will put the value of k0. Okay, so it will be summation n is equals to 0 to 3 x of n. Here it will be e raised to power completely 0, because if you put k is equal to 0, so anything in the power will be 0. So e of 0 is obviously 1. Okay. Now when you put the values of n from 0 to 3, you will get x of 0 plus x of 1 plus x of 2 plus x of 3. Correct. Now the value of x of 0 is 1. The value of x of 1 is 2. This is x of 2 and this is x of 3. So simply put all the values here. So when you put 1 plus 2 plus 1 plus 2, simply you will get 6. So the value of x of 0 will be 6 here. So we found this value x of 0. Next, we have to find x of 1. So to find x of 1, simply this expression will be changed like this. Summation n is equals to 0 to 3 x of n e raised to power. Here it will be minus j 2 pi by 4 whole raised to power 1 into n. Correct? Now when we put the values of n from 0, so in case of n is equals to 0, it will be x of 0 e raised to power 0, plus when we put x is equal to 1, it will be x of 1 e raised to power minus j pi by 2, plus when we put n is equal to 2, it will be x of 2 e raised to power minus j pi. When we put n is equal to 3, it will be x of 3 e raised to power minus j, it will be, I think, 3 pi by 2, correct? Yes. Okay, so the expression will look like this. Okay, now when we put the values here, so the value of x of 0 is 1, the value of e of 0 is also 1, so the first term will be 1. Now in the second term, it is x of 1. So the value of x of 1 is 1. So this term will, no, it is, sorry, it is 2. The value of x of 1 is 2. It is 2. Okay. So here we will have 2 here. Next, in order to find the value of e raised to power minus j pi by 2, how we can find this value? Okay. So just remember, e raised to power j or minus j theta is represented by cos theta minus j sine theta, like this. So if we want to find the value of e raised to power minus j pi by 2, it will be cos pi by 2 minus j sine pi by 2. Correct? And the value of cos pi by 2 is 0 minus the value of sine pi by 2 is 1. So yes, you will get minus j. So here you will get minus j. Correct? Similarly, for the next term, here it will be plus x of 2. So the value of x of 2 is 1. Okay, so it will be 1 and e raised to power minus j omega. Sorry, I have written it as omega, but it will be in fact
Pi.
yes, pi minus j pi. So if you want to calculate e raised to power minus j pi, it will be cos pi minus j sine pi. Correct? Uh,
Minus 1.
yes, minus 1 cos pi minus j sine pi.
Sir, minus 1.
Okay, so it will be minus 1. Yes, correct. Cos pi is minus 1 and sine pi is 0. Yes, correct. So it will be minus 1. Okay, plus in the next term it is x of 3. Correct. So the value of x of 3 is 2. And e raised to power minus j 3 pi by 2. What will be its value? Cos 3 pi by 2 is 0 and sine 3 pi by 2 is minus 1. So minus minus plus. I think you will get plus j here.
Yes. Plus.
Okay. So every time you will get only 4 value, either plus 1 or minus 1 or plus j or minus j. It is similar to that complex, that imaginary number. I raised to power n will always have any of the 4 values like this. Okay. So when you simplify this, tell me what is the value of x of 1? These two terms gets cancelled. Similarly, these two terms get cancelled and you will get 0 here. Correct? Uh, is there any doubt at this point?
No, sir.
No, sir.
Okay. Similarly, you have to find x of 2 also. Okay. So to find x of 2, now you put k is equal to 2 in this expression. and then again you have to solve it like this. And similarly, you have to find x of 3 also, and so on. Only up to 3, because we are finding the 4-point DFT, correct? So this is one of the example of DFT. Also, there is another way to find DFT, that is also called as fast Fourier transform f of t. However, I'm not considering that part right now. Okay. So these are the topics, that is DFT, DTFT, and Z-Transform, which I was supposed to explain you in today's class. Any doubt from today's session? Then you can ask me.
सर प्रॉब्लम्स की प्रैक्टिस ये प्रॉपर्टीज से करनी है ना, मतलब प्रॉपर्टीज के प्रॉब्लम्स प्रैक्टिस करनी है.
करेक्ट, हाँ, वो प्रॉपर्टीज से देख लेना. शॉमैन सीरीज में आपको बहुत सारे क्वेश्चंस मिल जाएंगे, तो आप उनसे प्रैक्टिस कर लेना, प्रॉपर्टीज और उसके एग्जांपल्स में. ओके.
यस.
और डीएफटी डीटीएफटी के कुछ एक दो प्रॉब्लम्स चेक कर लेना शॉमैन सीरीज से. ठीक है, दैट्स इट. और कुछ किसी का डाउट? ओके. ओके, सो अटेंडेंस पुट कर दो आपने. एंड कर रहा हूँ फिर आज की क्लास.